All right, so this is the key to topic 21, part B, worksheet 1, and this was the worksheet. And so notice that there are two problems, and you're given two quadratic functions, and they're both in general form. And then for each of those, you want to find the vertex, axis of symmetry, domain, range, y-intercept, determine whether it's concave up, concave down. Remember, the concave up is the same as is it opening up, or is it opening down, and so on. Okay, so in number one, I'm gonna go ahead and write number one. So number one, we have this g of x is equal to 2x squared plus 8x plus 5. Now remember, this is in general form. So if you're going to find the vertex and all that information in general form, the vertex in general form, you need to use the vertex formula. All right, and so here's the vertex formula. So remember, the vertex formula was this. So if you're going to find, and remember the vertex is hk, and so h, remember to find h, which is the x-coordinate of the vertex, x-coordinate of the vertex is going to be negative b divided by 2a. All right, so that's your x-coordinate. So this is the x-coordinate of the vertex. Now remember, once you find x, to find the y value, which in this case is g of x, you just substitute where we see the variable x, you substitute what you just found. So we saw that k would then be, in this case, g of negative b divided by 2a. Okay, so your vertex formula is this. So basically, another way to write this is you would say negative b divided by 2a, and then f of negative b divided by 2a, or g of whatever your function notation is. But that was a formula that we used. So negative b divided by 2a is the x-coordinate, or h, of the vertex, and then the k, or the y-coordinate, would be whatever your function name is. You would say g of that, or f of that, and so on. Okay? All right, so let's find the x-coordinate. So we've got to find the vertex. So that's part A. So part A says find the vertex. So to find the vertex, let's find the x-coordinate first. So the x-coordinate is going to be negative b divided by 2a. And remember, a, in general form, a is a coefficient of x squared. So a is, I'm going to go ahead and write it out here, right here. A is 2, and b is a coefficient of x, so b is 8. Okay? So then this becomes the opposite of b. So the opposite of 8 is a negative 8 divided by 2 times a. A is 2. So this becomes negative 8 divided by 4, which is negative 2. So I found the x-coordinate of the vertex. Now to find the y-coordinate, remember, once you find x, you just go back to your function, and wherever you see the variable x, you substitute negative 2. So the y-coordinate then would be g of negative 2. And so then that becomes 2 times negative 2 squared plus 8 times negative 2 plus 5. And so using the order of operations, a negative 2 times itself is 4. 4 times 2 is 8. And then this becomes 8 times a negative 2 is a negative 16 plus 5. And so this becomes negative 8 plus 5, which is negative 3. So therefore the vertex will equal, remember, xy. So it's negative 2, negative 3. So negative 2, comma, negative 3. So that's your vertex, okay? Now, once you find your vertex, so remember, once you find your vertex, then you know right away your axis of symmetry. So let's think about this. So in your mind, now remember, if A is positive, your parabola is opening up. It's concave up. So in your mind, you know you have something like this, okay? You now know the vertex. The vertex is negative 2, negative 3. Okay, and so your axis of symmetry goes through the vertex. So it's a vertical line that goes through the vertex. And notice the axis of symmetry, it just helps you to see that the parabola, that this side is symmetrical. When you reflect about the axis of symmetry, you get this side here. So those two pieces are symmetrical about the line y x equal, in this case, negative 2. So your axis of symmetry, just like a vertical line. Remember when you named vertical lines in previous courses, notice that every point on this axis of symmetry, the x-coordinate is always negative 2. So your axis of symmetry is x equal -2. And you must say x equal. Don't just say -2. So the axis of symmetry is -2. So in part B, you're going to say x equal -2 is the axis of symmetry. Okay? So it's very important that you say x equal. So far we know this. So far we know that the vertex is -2, -3. Make sure you put it in parentheses. The axis of symmetry is x equal -2. You must say x equal. Okay? All right. Now let's look at C. So C, they want to know the domain, and D, they want to know the range. Okay? And so let's talk about the domain and range. So remember, this quadratic function is a polynomial function. And so we know that all polynomial functions, the domain is all real numbers for all polynomial functions. Okay? We also know that if you look at the graph, if this were on an xy plane, when you remember the domain is a set of x coordinates, so when you go from left to right, you're going from -infinity to +infinity. So the domain is -infinity for +infinity, and when you're dealing with quadratic functions, that's the domain for all of them. The domain for all quadratic functions is -infinity to +infinity. Now, when you talk about the range, that's different. So remember in previous lessons and in previous topics, the range, remember, is a set of y coordinates. So you're going along the y-axis. All right, and so when you go along the y-axis, now this is not the y-axis, but you remember the idea. So when you go along the y-axis from bottom up, you start touching the graph at this point. See, and that points the vertex. And then remember the range is a set of y coordinates. So you got to look at this y coordinate right here. That y coordinate is -3. So you go from -3 all the way to infinity. So bracket -3, because this is a closed circle right here. So that point is on the graph. So bracket -3 to infinity. So that's your range. And then in part E, you want to find the y-intercept. Well, remember the y-intercept is where the graph crosses the y-axis. And no matter where the graph crosses the y-axis, x is always 0. So remember, to find the y-intercept, you let x be 0. All right, so there's now on the worksheet, didn't say anything about showing the, let's see, the y-intercept. Okay, all right, so you let x be 0. So then you go here to your function, right here, and where we see the variable x, you let x be 0. So we get g of 0 is equal to 2 times 0 squared plus 8 times 0 plus 5. And so 0 squared is 0, 0 times 2 is 0, so I get 0 plus 5, which is 5. And if you think about this, when a quadratic function is written in general form, the y-intercept, now that's only true if it's in general form, not standard form, but in general form, the y-intercept is always c. So your y-intercept, note that the y-intercept is c. It's c, it's always your constant, so 5. Right here, okay, and that's true because x is 0. So this term becomes 0, this term becomes 0, and you're left with your constant, which is 5. Now that's only true if this is in general form. Okay, so that was E. All right, so F, they ask you this. So F says, determine if g of x is concave up or concave down. So remember, to determine that, you look at A. So since A is positive, we just saw it here, right? It's concave up. It opens up. So for F, you're going to say it's concave up since A is positive. A is 2. All right, so far, let's go ahead and put some of our answers in here. So we know the domain is -infinity to infinity. We know the range is from -3 to infinity. We just saw the y-intercept is 5, or you can write as a point, so it'll be 0, 5. And now we know it's concave up. All right, so concave up. And then, in fact, you could have answered that at the beginning. Since A is a +2, we know right away it's concave up. Then they want to know, is the vertex a maximum or a minimum point? Well, notice that the parabola is concave up, the function is concave up. So this is the lowest point on the graph. So that's a minimum point. So the vertex is a minimum point. All right, so make sure you read carefully. So it says this. So is the vertex a maximum or minimum point? Well, it's a minimum point. So minimum point. All right. So then it says fill in the blank. So the blank value of g of x is blank. So for the first blank, use either minimum or maximum. Well, we know that this is a minimum point, right? And so we're going to say the minimum value. And when you're talking about value, you're talking about the y-coordinate. That's important. Y-coordinate. Not the point, the y-coordinate. So the minimum value of g of x is, and the smallest y value, and we saw it here, right? From the range, the smallest y value is -3. Okay? And that's all they wanted you to do. They didn't ask you to find the x-intercepts, and they did not ask you to graph this. That's all they wanted you to do in this worksheet, worksheet 1. Okay, now we're going to do the same thing with the second function. So in the second function, now notice that the difference, besides the functions being different, but if you notice A here is negative. Okay, so this one A is positive, this one A is negative. Okay. All right, so let's write the function down. So in this case, h of x is, and this is number 2. So h of x is -3x squared plus 6x minus 8. And then I want you to find the vertex. So again, we're going to use a vertex formula. So that's letter A. So the vertex, remember, is negative b divided by 2a, and then h of negative b divided by 2a. So that'll give us a vertex. So the x-coordinate of the vertex will equal, now in this case, notice that a is -3 and b is 6. Okay, so then the x-coordinate becomes negative b divided by 2a. So the opposite of b, so b is 6. The opposite of 6 is -6 divided by 2 times a. A is -3. So that becomes -6 divided by -6, which is 1. So the x-coordinate of the vertex is 1. To find the y-coordinate of the vertex, you're going to substitute 1 into your function. So basically you're finding, in this case, h of 1. And so we get -3 times 1 squared plus 6 times 1 minus 8. So 1 squared is 1. 1 times -3 is -3. 6 times 1 is 6 minus 8. So I get 3 minus 8, which is a -5. So my vertex is 1, -5. So the vertex is 1, -5. Okay. Now to find the axis of symmetry. So think about that. So let's go ahead and notice that the parabola opens down, so it's concave down. All right, so you get something that looks like this, right? You just found the vertex, and the vertex here is 1, -5. Okay, and so your axis of symmetry is a vertical line that goes through the vertex, and notice that it divides the parabola into 2 equal symmetrical parts. So the parabola is symmetrical about the line, about the axis of symmetry. Now you have to determine the axis of symmetry. So that's part B. So part B, remember there's a vertical line. So in a vertical line, the x-coordinate is always the same thing. In this case, it's always 1. So you can say x equal 1 is the equation for the axis of symmetry. So x equal 1. So that's your axis of symmetry. Okay. Then part C, they want to know the domain. And part D, they want to know the range. All right, so remember, this is a polynomial function. It's a quadratic function, and you know that the domain from all is all real numbers, so from -infinity to infinity. Okay, now remember, you have little arrows here, so from -infinity to infinity, so that's your domain. And remember, the domain for all quadratic functions will be all real numbers, -infinity to infinity. Now, when doing the range, so remember, when doing the range, just from previous experiences, you're going from bottom up. So notice that these arrows are pointing down. So as you go from negative infinity, this is the highest point on the graph, right? And so that y value is negative 5. So you're going from negative infinity to negative 5 with a bracket. All right, so it's D. And then E, they want to know the y-intercept. Well, remember, to find the y-intercept, you're going to let x equal 0. So basically, you're finding h of 0. So you're saying h of 0 will equal negative 3 times 0 squared plus 6 times 0 minus 8. And so 0 squared is 0. 0 times negative 3 is 0. 6 times 0 is 0. And you're left with negative 8. And we knew that the y-intercept had to be negative 8 because that's your constant. So whenever it's written in general form, your y-intercept is always this, because remember, to find the y-intercept, you let x be 0. Well, if x is 0, then this term 0, this term is 0, and you're left with c. So your y-intercept is negative 8. All right, so let's go ahead and fill in some information at this point. So we found the axis of symmetry. So the axis of symmetry is x equal 1. We found the domain. It's all real numbers. In fact, the domain of all quadratic functions is all real numbers. We found the range. So the range is negative infinity to negative 5. Remember, the order matters. So don't say negative 5 to negative infinity. You go from smallest to largest. The y-intercept is negative 8, or you could have said 0, negative 8, because x is 0. Okay, so now we also know that the parabola is opening down, right? So it's concave down. We knew that just by looking at A. So if A is negative, it opens down, it's concave down. So F, we're going to say it's concave down since A is negative, less than 0. All right, and then G, remember, they want to know, is the vertex a maximum or minimum point? Well, you know that it's a maximum point, right? That's the highest point on the graph. So that's a maximum point, okay? And then it becomes, all right, so fill in the blank. So the maximum value is, and remember, it's always the y-coordinate. So your maximum value is the largest y-coordinate, which is this y value of your range. All right, all right, so we know it's concave down. It's a maximum point. Okay, and we know that the maximum value is, and in this case, negative 5. All right. Okay, now remember, don't put the point. So don't say, and it's important. Remember, the y, when they ask for the value of h of x, remember, h of x is y. So remember that h of x is y. So when they're asking for that maximum value, they want to know what's the maximum value of y. Well, the maximum value of y is negative 5. All right, so it's important you put negative 5 and not the maximum, and not the vertex. Don't put the vertex, you put the y value, because it does say maximum value of h of x. Remember, h of x means the same thing as y. Okay? All right, so that is the key to worksheet 1 of topic 21, part B.